Hey guys, so this video is about lines and graphing lines and everything about lines. So right now on Desmos.com, the graphing calculator, which is so good and everyone should use it and play around with it. And actually, just to pique interest, I'm going to do a kind of cool thing. And this isn't even like the coolest thing that this thing can do, but watch this. You can make a little wave. I know it's crazy. Anyways, go on here and play around and stuff and try to make different graphs. Anyways, so right now we have y equals x, and this is corresponding, this y equals x right here is corresponding to this line on the coordinate plane here. So as you can see, this is going through 0, 0, right, the origin, is going through 1, 1, it's going through 2, 2, and just everything here. You know, it's also going through -1, -1, -2, -2, stuff like that. So I think a good way to think about lines in general is just kind of like infinite points, I guess. Like, this is 2, 2 here, right? But, I mean, as you can see, I'm also getting 1.99, 1.99, 1 point, it's going all the way here. And this is also stretching out infinitely in both directions. So yeah, it's infinite. It's infinitely small. Like, this could be 1 point, 0.14, 0.148. This could go infinitely like that. So that's what a line is. It's basically just a set of infinite points, and it's linear. And we're gonna get to that. But basically, think of this as inputs and outputs. Like, if we plug in a 1 for this x here, then this y, because it's equal to x, would also be 1, right? Like, if we, and that's this point here. If we plugged in a 2 for this x, then this y value is also going to be 2 because y is equal to x. But let's say we had another line, and when it wasn't y equals x, it's y equals 2x. So as you can see, there's already a pretty big difference between these two lines. Let's just see what we notice about them, right? Let's see. Well, this one, it's not a lot. It's steeper than this y equals x, right? This y equals 2x is steeper than this one. Think of them as like hills, right? Like, if you're running up this hill, like, that would be tough, right? But if you're running up this hill, that's just like, you're basically climbing at that point. So try to think of them as hills. Another thing we can notice is that if we consider that input-output thing again, right? Like, if we plug in 1, on y equals x, it's 1, 1, right? But over here, it's 1, 2. If I could get there, yeah. And if we plug in 2 for y equals x, obviously we know that y is going to also be 2, so our coordinate system is 2, 2. But if we plug in 2 here on the y equals 2x, then it's going to be 4. So again, basically, all this means that y is going to be 2 times whatever value we plug in for x. That's all that means. And because of that, there is infinite points that we can plug in for this, meaning it forms a straight line. Okay, now let's see what we notice about y equals 1/2 x. And this is a fraction now. So, okay, this would be so much of a better hill to run up than either of those other two. So it's less steep. Instead of, when we plug in 1 here, instead of it being 1 or 2 like the other ones, this is actually 0.5 for y. And that makes sense. If we plug in 1 here, 1/2 times 1 is going to be 1/2. If we plugged in 2 for x, 2 times 1/2 is going to be 1. So what we're noticing is that when you have greater values right here, right next to the x, multiplying to the x, is going to be a steeper line. And if you have smaller values, like, this one is less steep than the 2x, but this 1/2 is less steep than either of those two. So let's see what happens. Well, actually, let's just kind of test that theory. Like, what if we plug in y equals 4x? Okay, so we know that's true. It's still getting steeper. What if we change that 4 to 100? Okay, yeah, that's super steep, so that makes sense. But let's do, like, an even smaller fraction, right? What if we did 1/8? Yeah, that's still less steep. So basically, the higher you go for this number, the steeper the line gets, and the smaller the fraction is, the less steep it gets. But you might be thinking, well, what about negative numbers? What if it was negative 1/8 or something like that? So let's see what happens. Okay, interesting. So I'm gonna get rid of the other ones. We're just gonna keep y equals x and y equals negative 1x. Alright, so basically they're just kind of mirror images of themselves, right? This one's going up and to the right, and this one's going down and to the left. And if this was 2x, and this was negative 2x, same concept, right? You can split it, you can kind of think of this as a mirror, right? Maybe there's a mirror going up and down, or you're folding the paper or whatever, or you're folding it up and down like this or like that, but they're still symmetrical. And yeah, honestly, that's all the negative does there. It just changes it. Instead of going up and to the right, which is a positive slope, right? Kind of a positive hill, I guess. You would be running down the hill if with a negative slope. It's going down into the right instead of up into the right. Sorry, I think I misspoke earlier. Negative is down into the right. Positive is up into the right. Okay, that's good. So let's try to do some other stuff with this graph. Like, we're just multiplying stuff to this x value, right? Oh, and I mean, you could also multiply stuff to this y value. You could also do stuff there, but generally we kind of just leave the y and set stuff equal to the y instead of the other way around. But you could also be like, x is equal to 2y or something like that. Which is really, actually, that's good. What is this equal to when we solve for y? It's y is equal to 1/2 x, which is exactly what this is. Okay, so that's just good to know. Let's say we are trying to do other stuff. We're just multiplying this x by other numbers right now. We're not really doing much else. But we also have other operations just in math in general that we can do. So what if we just like added something here? All right, well, that was interesting. We just shifted it all up. But what's also cool is that these two lines are parallel right now, right? These are going on infinitely and not touching each other. Because they have the exact same slope, but they're at different points. They're touching the graphs in different places, right? If I move this up 2, it'd be the same concept. So really, when we're adding stuff here, it looks like it's just getting shifted up. So try to predict what'll happen if I did a -2 instead of a +2 here. Okay, so let's try it. All right, so looks like it shifted it down. Okay, so I'm just going to explain kind of what the formula actually is, because there is a formula for this in math that has specific letters for it. So this right here is really called y equals mx plus b. And this m just stands for this number here, right? It could be any number. And this b is whatever number is right here, right? It's whatever is being added or subtracted to it. So the m is the slope. And we know it's a slope because whenever we played around with this kind of stuff, right? And we imagined it like a hill, it was how steep or not steep that slope was. So that's all this is. It's just telling us how steep or not steep the line is. And this is really telling us how much we shifted up or down. Because, again, if this is just y equals 2x, if we plugged in, like, 0 here, we'd get, 2 times 0 is 0, so y equals 0. So it's going through the origin, 0, 0. But if we plugged in 0 to this 2x minus 2, then this would be 2 times 0 is 0, and then minus 2. So this y would actually be shifted down -2. So you can think of this as how much the graph is shifting, or also this b value can be thought of as kind of the y-intercept where the graph crosses the y-axis. So like if this was a, a -1, it's crossing it at -1. If this was a +1, +1, it's crossing it at +1, but the whole graph is shifted up. Anything else? Yeah, so just one other quick thing. It's pretty straightforward, but what if we just set, instead of y is equal to x, what if we just set it equal to some number, right? What if it was just equal to 3? So this graph, this right here, this line, is y is equal to 3. And I mean, that makes sense. Whatever you plug in at all for the y, it's always going to be 3. And looky here, it's always going to be 3. So if we did x is equal to 3, our x value is literally always going to be 3. Like if I drag this here, this 3 doesn't change at all. And if I drag this here, this 3 doesn't change at all. So that is all that means. So basically, to sum up, think of the slope or the m value as kind of a hill and how steep or not steep it is. The higher that number is, the more steep it'll be. And the closer to 0 it is in terms of fractions, the less steep it'll be. There's also negatives, which just kind of reverse the whole graph. It's just a mirror image of it. You can add or subtract stuff, which shifts the line up or down. And if you just set a number to it, then it kind of works out exactly how you'd expect, right? This y value is always going to be equal to 3. This x value is always going to be equal to 3. So there's just going to be straight lines up and down or side to side.